Good day. I am Clyde Narbasa, a BS Math, BS Ed Math 2 students at Visayas State University, Isabel. And today, I am going to discuss relations, in set and logic theory. First, ordered pairs and Cartesian plane. So, before anything else, I have here uh, some sort of questions to help you better understand what is ordered pair. So my first question is, name two of your favorite fruits. So maybe you will answer, for example, you will answer grapes or strawberry. And then I will ask you, if you had to pick only one, which one would you pick? So maybe you would pick strawberry because that's your very favorite na fruit. Kanang kuan, so moingon ko, what's your favorite fruits? You will say strawberry and grapes. Kanang kuan, pwede ra siya, ang imong tupag, pwede ra siya strawberry or grapes or grapes or strawberry. Since that two is your favorite fruit, so pwede ra ma-interchange, no? However, when I will ask you kanang your top two favorite fruits arranged in order of preferences. So, since moingon ka ganina nga ang pinaka-favorite yun nimo is kanang koan, tawag ani ang strawberry. So, more likely ang imong itubag strawberry o ganang grapes. Since pinaka-koan man nimo, pinaka-gusto man nimo ang strawberry. So, dili siya pwede kanang grapes to strawberry since in ordered man, 'di ba? Kay mas koan biya, mas kanan biya ka sa strawberry. So, kana siya. So, does order really matters when it comes to math? So, I have here. So, natay duha ka figure, right? It is a line and a ray. So, look at the line. So, we have here line AB. We can name this line AB or line BA. So, it's just the same since it's a line. So, line AB is just equal to line BA. So, in this case, order doesn't really matter. However, so let us look sa rays. So, we have here ray AB. So, is it okay to call this ray BA? No, because the order or the arrangement of the the point is very important in identifying a ray. Since when we say ray AB, so ang iyang direction from A along B. So diretso. But moingon tag kanang moingon ta og ray BA. So the end point is at B. So muditso siya to A. So we cannot say that ray AB is equal to ray BA. So here, order really matters. Okay, let's proceed. So, first, let's have a definition of what is really an ordered pair. So, I already gave two examples, yet I still didn't explain what is ordered pair. So, here it is. So, the ordered pairs of A and B is a set denoted AB with the parenthesis. So, I hope you know the difference between parenthesis and a bracket. So, it will help you. So, when we say parenthesis, kato lang curve. So, when we bracket, kato murag na tumoy, kato. That's what we call the bracket. So, where A is the first coordinate of the pair, AB. So, where A is the first coordinate of the pair, AB, and B is the second coordinate, defined by ordered pair AB is equal to the set of A and AB. So, if A is not equal to B, then the set AB has two elements, a singleton A and an ordered pair AB. So, let's proceed. So, we can find the first coordinate by looking at the element of A and its second coordinate as the other element of AB. Clearly by this, AB is not equal to BA, since AB or the ordered pair AB is equal to A, katong singleton A, and AB, while BA is equal to B, BA. So, dili siya pareho. So if A is equal to B, then A is equal to kanang singleton A, then A. It's just A kay ato mang-replace si since di ba kay A is equal to B. But pasabot si B, pwede na to siya i-replace or i-substitute si A. So if ingana ang mahitabo, if A is equal to B, but pasabot kanang naratay single elements. So which is A ra. So let's proceed. So natay theorem dere. So a theorem ordered paired AB is equal to ordered pair A prime then B prime. If and only if kanang A is equal to A prime and B is equal to B prime. So natay proofs ari. Suppose that A is equal to A prime and B is equal to B prime. So, di ba, equal si A o si A prime, then B and B prime. So kanina, atong gisuwat nga, A ordered paired A, B is equal to katong singleton A nga AB. So, ang katong A, ilis na nato og A prime. Og katong B, ilis na nato og A prime. So, dira, makaingon na ta na si AB is equal to A prime, B prime. So, another proof. So, let's assume that AB is equal to A prime, B prime. That is, A tapos katong unordered pairs na AB is equal to A prime tapos A prime, B prime. So, if A is not equal to B, then A and AB is equal to A prime, B prime. And that is, A is equal to A prime and AB is equal to A prime, B prime. So, if A is equal to B, then mara itong hihitabo ganina, gi-substitute ra nato, so murarag si A ra ang nabilin. So, let's proceed. Nata example dire. So, as you can see, it is a Cartesian plane, diba? We have the y-axis, the x-axis. So, I have here two different points, two different coordinates, two different ordered pairs. So, we have the number 1, 3. So, my question is, does the kanang coordinate 1, 3 the same as 3, 1? No. Since, diba, sa 3, 1, the x, ang point na to sa x is 3, while ang y kay 1. While sa 1, 3, ang x na to is kanang si 1 and y is 3. So, it's not the same. So, two different points since two different orders. So, let's proceed. Pwede na to i-associate, diba? Since kay bawa naman ta ganina nga si kanang si xy si 3 sa 3, 1 is x and y. So, pasabot si x corresponds to 3, y is corresponds to 1. So, ma-apply na to diri ang theorem, diba? Kay gi-equate man nato si x ug y equal to 3, 1. So, two ordered pairs are equal if their corresponding elements are also equal. So, naingon nato nga si ang ordered pairs na xy is equal to the ordered pairs 3, 1 since x is equal to 3 and y is equal to 1. So, let's proceed. I have here a sample problem. No. So, if x plus 1, if the coordinate, ordered pairs x plus 1, comma, y minus 2 is equal to 5, 3, then find x and y. Since kanang giingon naman diri nga equal sila, so all we have to do is to equate them. So since x plus 1 nato dira is equal kanang kuan man siya kanang tawag ani corresponds to the element 5. Kasi unsay nag-una mapinag-una sa pika, so equal sila. So x plus 1 is equal to 5, then kanang subtract both sides by subtract both sides by 1, so x is 4. Sa pikas pod is y minus 2. So kanang 2y minus 2 is equal to 3 since the y coordinates is corresponds diri sa pikas 3, which is ang pangaduhang coordinates. So, i-equate naman silang duha and let's kanang add both sides by 3, so, 2, that becomes 5. So, nanatay answer nga, kanang ang x nato is 4, then y is 5. Now, let's proceed sa ato ang Cartesian product. So, what is Cartesian product? So, it consider two arbitrary sets A and B. So, the sets of all ordered pairs AB, where A is an element of A and B is an element of B. It is called the product or Cartesian product of A and B. So, a short designation of this product is A, tapos ang multiplication nga cross nga symbol B, which is read A cross B. It's just the same. So, kanang Alderpod frequently writes A squared instead of A times A, since it's just the same, ano. So, natin example dira. So, R denotes the set of real numbers, and so R squared is equal to R times R is a set of ordered pairs of real numbers. So, this set is frequently called the Cartesian plane. Mana itong gitawag nga Cartesian plane. Set of all real numbers is what we call the Cartesian plane. So, for example, natay ang A na to, natay set, no? We have two sets, A and B. Our set A is, ang elements sa set A is 1 and 2, while the elements in set B is A, B, C. So, when we say A cross B, or the kanang kuan, Cartesian product of A and B, so we just simply kanang pair, no, si A o B. So, first, mura siya tawag ani, gi-distribute first, gi-distribute nimo ang coordinates ni set A to set B. So, syempre, mag-una ta sa kanang first coordinate ni set A. So, i-distribute nimo siya sa B. So, manang natay 1A, kanang ordered paired 1A, 1B, 1C, tapos after 1C, si 2 na sad sa set A. So, 2A, 2B, 2C. So, it's just the same if baliktaron nimo. So, the Cartesian product of B and A, syempre, mag-una na, ang i-distribute na nato karon is ang set B. So, mag-una sa A, i-distribute sa 1 ug 2 sa kanang kuan set A, manang na ay A1, A2, A1, B1, gi-arrange na niya, guys. A1, palit, pero na may A2 dira, gi-arrange na niya. So, if pwede po din mo kanang kuan Cartesian product sa A, no, A lang. So, unsa man itong buhaton, ana. So, duha ka set A, yun niya, i-distribute ni mo. So, manang na 1, 1, 1, 2, 2, 1, 2, 2. So, now let's proceed. So, para kuan so we can understand more what is really Cartesian product of sets. So, for example, kanang after a very tiring kanang class, no, so it's lunchtime. So, nakaiduha ka choices is either to go out to buy or order na lang. Then, your choices of your food is pizza, burger, or ice cream. So, mana siya. So, natay duha ka kanang kuan. So, ang actions nato og ang unsa atong food nga atong gusto. So, if we were kanang group that, diba? Kanang natay 6 possible combinations or mao na atong gitawag nga ordered pairs. So, order tapos pizza, order tapos burger, order tapos kanang ice cream, or go out tapos pizza, go out tapos burger, tapos go out tapos ice cream. Mao na ang atoang mga kanang 6 possible combinations. So, ang naguna is what we're doing or ang actions. Ang pangaduha is what we're eating. So, kanang unsaon man pagkahibaw kung pila ka in doing kanang Cartesian product, unsa pagkahibaw nga pila ka buok combinations or ordered pairs ang naa sa answer. So, we just simply kuan lang. Kanang tawag ani, i-multiply kung pila ka elements. First ang set, tapos i-multiply nimo kung pila ang elements sa pangaduha nga sets. Before tamo dito diri sa ta. So, kuan daw, if katong mga 6 possible combinations or the ordered pairs, kiisud nimo siya sa usa ka sets, mao na natong gitawag nga one Cartesian product of sets. So manay one Cartesian product of sets. So let's proceed na sa giun sa pagkuha sa total number of elements. So ang ato ang sets of what we're doing matong P. So, di ba natay duha ka choices is either go out or order. So, duha. Then, ang atong sets of what we're eating, ang Q, natay tulo. Pizza, burger, or ice cream. So, in order to know kung pila ka puok, ordered pairs, ang sud sa imong usa ka set, or sa imong Cartesian product, so we just simply multiply 2 times 3, then we have 6. So, manang natay tulo ay 6 ka ordered pairs. So next, nata example dira. So we have here an example of we have set P, which the elements of set P is 1 and 2, and set Q the elements is A, B, and C. So find the Cartesian product of P and Q. So man na siya atong answer. 1A, 1B, so gidistribute na nato si 1 sa pikas. 1 sa 1 gidistribute sa A, nya gidistribute na pud sa B, gidistribute na pud sa C. After that, si 2 na sad. Gisod si, di ba ordered pairs man na sila, so parentheses. Nya ang kanang mga parentheses gisod og bracket. So same sa kuan, kanang giun sa pagkuha kung pila sila ka buok, since si P is naatay duha ka elements, tapos si Q kay naatay tulo, so 6 man ang inyong ipondera na sa usa ka kuan, sa usa ka set natay 6 ka ordered pairs. And mao na siya example sa finite set, since ang sud sa set kay maihapraman, so we call this finite. So next is kaning kuan natay given, same nga given. Same ang first given, which is ang P is kanang sud sa ang element sa P is 1 and 2. However, si Q na to dira is a null set. So, diba, we always knew that a number multiplied by 0 will always be 0. So, in finding the number of kanang tawag ni ordered pair sa kaninga set, since ang first set na to is 2 and second set na to is 0, so which means kanang it gives us 0. So, but pasabot, kani siya nga Cartesian product will leads to an empty set. So, wala kay pairs, since 0 man si pikas. So, ba na itong gitawag nga empty sets. So, next is, ang given kay P, ang element sa set P is 1, 2, and sa set Q is 1, 2, 3, ellipse. So, but pasabot, it goes all the way without bounds. So, ang pangutan na, how do we know how many kanang ordered pairs in that set when in fact kanang si atong pangaduhang set is infinite? Simple. So 2 multiplied by infinite will always gives you an infinite number. That's why kanang this is an example of infinite set. So in constructing pwede ra ka mohatag og siguro mga 4 examples, then butangan na lang nimo og ellipse nimo to highlight that this set is an infinite set. But pasabot kanang it goes without bounds. So next, so naipangutan na diri is P times Q is equal to Q times P. So for example, kanang is P is kanang ang elements ni set P is 1 and 2 and Q is ABC. So if kanang ikuan na nimo siya, di ba natay answer sa Cartesian product of P and Q and Cartesian product of Q and P. As you can see, once na inyo nang distribute ang mga elements sa pikas nga set, kanang it gives us the reverse of kanang ang Q and P is the totally reverse or opposite of P and Q. So, di ba panalitan sa ilang first kanang ordered pair, si P and Q is the ordered paired 1A, while sa Q times P is A ug 1. So, does ordered pair 1A is equal to A and 1? Of course not, since we need we need the two ordered pairs to be identical, like totally identical, like for kanang especially in arrangement to be able to call it kanang equal. So since di man sila pareho, so it's not equal. So that means that the Cartesian product of P and Q is not equal to Q and P. However, no, the number of elements will be the same, but the number of elements is not will never be a basis kanang to conclude that the two Cartesian product or the sets of two Cartesian product is equal. So we have here a types of relation. So first, let us define what is relation. So let A and B be sets. So a binary relation or simply relation from A to B is a subset of Cartesian product of A, B. Suppose R is a relation from A to B, then R is a set of ordered pairs which each first element comes from A and each second element comes from B. That is, for each pair, A is an element of A and B is an element of B. Exactly one of the following is true. So, AB is an element of real numbers. We then say A is related to B when A are B. Tapos ordered pairs AB is not an element of R when we say A is not R related to B when A tapos R tapos naa siya kanang slant nga line to indicate na it's not R related to B. If R is a relation from set A to itself, that is, if R is a subset of A squared or kanang kuan is equal to A times A, we say that R is a relation on A. So, to better understand, I have here kanang kuan examples. So, for example, we have here A, 1, 2, 3 ang elements sa set na A. While sa B, X and Y. So, first, we get the Cartesian product of A and B. Since we already know, giun sa to pagkuha sa Cartesian product, diba, gidistribute naman to nato, ang para, gidistribute nato sila to make an ordered pairs, tapos solve nato siya sa sets. Then, we are given a relation, or like ang kaning R na to. Tanawon nimo ang R. Diba natay duha ka given nga ordered pair sa R? It is 1 og X og 2 og Y. Thus, one ordered pair 1X and 2Y belongs or subset to Cartesian product of A and B. So, if yes, then R is a relation from A to B since R is a subset of the Cartesian product of A and B. So, ingana ra pag-identify if whether that given set is a relation. Okay, so for the first type of relation is reflexive relation. I know reflexive is very familiar since kanang in basic algebra we have kaning kuan ni gisugatan na ni nato. So first, let us define what is it. So a relation R on a set A is reflexive if A related to A for every A is an element of A. That is, if ordered paired A is an element of R for every A is an element of A. Thus, R is not reflective if there exists A is an element of A such that AA is not an element of R. So to put it simply, I have here examples to further understand because the definition is very wordy and it's very technical. So I have here an example. So first, consider the following 5 relations of the set A. So the set A has 4 elements which is 1, 2, 3, and 4. Then we have here kanang R sub 1 to 5. So identify kung nung asaan na nila is kuan kanang reflexive. Okay, so we have here solution. Excuse me. Since A contains the 4 elements 1, 2, 3, 4, a relation R on A is reflexive if it contains the 4 pairs. For example, kanang ordered pair 1, 1, 2, 2, 3, 3, 4, 4. So dapat pareha sila. Ang first coordinate and second coordinate must be the same element. Thus, only r sub 2 and the universal r sub 5 is equal to a times a are reflexive. So note that r sub 1, r sub 3, and r sub 4 are not reflexive since, for example, kanang the ordered pair 2 and 2 does not belong to any of them. So, look at the kanang r sub and r sub 2. So, para daw ko no, maingon na reflexive siya, dapat kanang, di ba sa atong elements of A, natay upat ka kanang elements which is 1 to 4. So, in order ko no, mahibaw na to, nga reflexive siya, dapat ang sulod sa imuhang kanang kuan, sa imong R, is kanang pair siya, identical pairs sa each kanang elements. So, for example, 1, 1, 2, 2, 3, 3, and 4, 4. But, if you look at the kuan, di ba, sa R sub 2, makita na nato nga naa si kanang ordered pair 1, 1, 2, 2, 3, 3, and 4, 4. So, that makes it reflexive. Even though naatay pair nga 1 and 2, but still, since naman dito sa kanang kuan, so, katong ordered pair 1, 1, 2, 2, 3, 3, 4, 4. So, it's still kuan reflexive. So, thus, kanang kuan, kaning R sub 5, since it is the Cartesian product of kuan, A and A. So, i-distribute raman nimo. So, basically, ma-appeal ra dito si kanang 1, 1, 2, 2, 3, 3, 4, 4. So, we have here another example. So, kanang kuan, so set A is 1, 2, 3, then naatay kanang relation R nga given diri. So, in order to identify whether it is reflexive or not, kanang look at the elements of the sets. Look at the ordered paired elements sa sets. If kompleto gani ni ang kanang kuan, ordered pairs nga 1, 1, 2, 2, 3, 3, like dapat sa usa ka ordered pairs, kung unsay nag-una panalitan sa set A, dapat parehas na identical ang imuhang kanang first coordinate ug second coordinate, and dapat kato siya nga mga elements are katong elements nga makita nimo sa set A. So, ay mo pangitaon dira is 1, 1, 2, 2, 3, 3. So, naa ba? Since wala man nato, di man nato makita si ordered pair nga 3, 3, so we can say that the set of R is not reflexive. So, dili siya reflexive since wala ay 3, 3 ana, ordered pair 3, 3. So, let's proceed to symmetric relation. So, let us define a relation R on a set A is symmetric if whenever A related to B, when B relate to A, that is, if whenever A ordered pair A and B is an element of R, then B ordered pair B and A is an element of R. Thus, R is not symmetric if there exists A and B is an element of A, that A and B is element of R, but B and A is not an element of R. So, to put it simply, so I have here a kaning koan more siya visual representation. So, the first circle, so natay dira 1, 2, 3, 4. So, mana ang mga elements sa sulod sa usa ka set. Nasa pangaduha is 1, 2, 3, 4, the same. Okay. So, look at the first circle. So, ang atong pagtan-aw sa ang kanang line is from left to right. So, first natong buhaton is i-connect, isuwat na to ang mga ordered pairs na na-connect sa line. So, we have here 1, 2, 2, 1, 3, 4, and 4, 3. So, in order na ko no, para may bawaan na to nga, kanang symmetric siya, dapat kanang naatay, kanang murag, panalitan is, ang naatay reverse sa ato ang first nga ordered pair. So, since ang atong first ordered pairs is 1, 2, dapat napuntay 2, 1. Ang pangaduha na to is 3, 4. So, dapat na ay 4, 3. Since naman sila, diba? So, we can say that it is symmetric. Next, proceed. Since natin diri pangaduha, so, nagapon tayo mga kanang lines. So, we will write first the ordered pairs connected by this line. So, we have 1, 2, 2, 1, 3, 4. So, as, if imong tanawon, si 1 and 2, diba, naaman iyang reverse, which is the 2 and 1. Or opposite niya. However, si 3 and 4, wala man. So, we cannot say this is symmetric. Kay what may 4 and 3. So next, kini, it is very tricky no kay si A gi-connect ra siya sa A rasad. Si C gi-connect ra siya sa C. So, does kanang kuan ba symmetric ba ang elements if kanang iyang i-pair siya sa iyang itself? So the answer is yes. So panalitan 1 1 is symmetric since kung imo nang balihon 1 1 ra man gapon. So pwede ra siya wala na ilain nga kanang kuan pa like wala na siya ilaing kanang lines ba dira because kanang it is kanang understood that A and A is symmetric since kanang kuan an element itself is symmetric to itself. So that's why kaning ato ang third example is symmetric relation. So unsaon man sad if wala tay mga visual representation like circle. So we have here, so for example, in a given set A, we have 1, 2, 3, 4 nga elements. Sa atong set R, napud tay mga ordered pairs dira. So ang imo nang buhaton is tan-awon nimo. First nimo tan-awon nga ordered pairs 1 1. Diba? Understood naman siya nga it is symmetric naman jud siya sa iyang kaugalingon. So pwede rag wala na ilain di na ka magsuwat paglain 1 1. So it's understood na. So next ordered pair is 2 3. So dapat makuha nimo ang opposite ni 2 3 which is the 3 2, which is makita man pud siya sa nagsunod. Next is 4 3. So dapat na sa atong sets dapat na ay 3 4. And since na may 3 4, so this means that this sets is symmetric. So next, the last kanang kuan types of relation is transitive relation. So let us define when R on a set A is transitive if whenever A relate B and B relate C, then A relate to C. That is if whenever ordered pair A and B, B and C is an element of R, then A and C is an element of R. Thus, R is not transitive if there exists ABC is an element of R such that AB, BC is an element of R but AZ is not element of R. So to put it simply, natay ka ng kuandari visual representation. If si A is equal to B, then B is equal to C, meaning A is equal to C. So mura siya kanang rule sa transitive no when it comes to algebra. Same lang. So we have here an example. So first thing you must do is write the ordered pairs that connect by the dot. So that ay 1 and 2. Next is 1 and 3. The next is 2 and 3. So as kanang look at sa ordered pairs nga imo nang nasuwat. 1 and 2, 2 and 3, meaning 1 and 3. So, di ba? 1 and 2, 2 and 3, meaning 1 and 3 is kanang equal lang sila. So we can say that it is transitive. Another, first list all the ordered pairs connected by the line. So natay ordered pairs 1 and 2, 2 and 3, 3 and 4. So, is it transitive? No. Since to make it transitive, dapat ang last na tong ordered pairs is kanang 1 and 3. But since it is 3 and 4, so dili siya transitive at all. Although, sa arrangements nila sa usa ka set, dili siya magmatter whether mag-una si kanang 2 ug 3, 1 ug 2, as long as kanang makita ang ilang relationship sa tulo ka ordered pairs. So another example, we have here, sa set A is X, Y, and Z. And sa kanang set R, natay ordered pairs ng X, Y, Y, Z, X, Z. Is it transitive? Yes, it is transitive. So now, let's proceed to our last topic, which is the equivalence relation. So by the word equivalence, which means equal. Since we have here a definition, so consider a non-empty set as a relation R on S is an equivalent relation if R is first symmetric, first reflexive, B symmetric, and transitive. That is, R is an equivalence relation on S if it has the following three properties. A. For every A is an element of S, A relate A. If A relate B, then B relate A. If A relate B and B relate C, then A relates C. So the general idea behind an equivalence relation is that it is a classification of objects which are in some ways alike. So in fact, the relation equal of equality on any set S is an equivalence relation, that is, A isn't equal to A for every A is an element of S, A isn't equal to B for then B is equal to A. If A is equal to B, then B is equal to C, then A is equal to C. So, to put it simply, in order for us to tell that a set or a relation is an equivalence relation if it is can satisfy all the three conditions. First, it needs to be reflexive. Second, symmetric. Then third, transitive. So question is, can we still call this kanang kuan equivalence relation if it is only kanang reflexive or symmetric but not transitive? Of course not. So it need to satisfy all the three conditions. So first we have here an example. So let L be set of lines in the plane. Then the relation is parallel to or identical to is an equivalence relation on L. So we all know that line L will always be identical to itself, meaning it is reflexive to itself. Diba? Next, if line L1 is parallel to or identical to line L2, then L2 must also be parallel to or identical to line L1. If two lines are parallel, means they are identical, right? So that means they are symmetric. Because we can equate two lines. I mean, line A is equal to line B, and it's just the same as line B is equal to line A. Next, transitive. If line 1 is parallel to or identical to line 2, and line 2 is parallel to or identical to line 3, then line 1 must be parallel to or identical to line 3. So in geometry or Euclidean geometry, two lines parallel to the same line ay parallel to each other. So if natay line A, B, ug C, so if parallel si line A ug B, then si B ug C is parallel also, but pasabot si line A ug line C is also parallel. So let's proceed to another example. So let T be set of triangles in the Euclidean plane. So then the relation is congruent to and or similar to our equivalence relation on T. So first, let us evaluate if this example can passes through our three conditions. It must be reflexive, symmetric, and transitive. First, reflexive. So any triangle T is congruent to itself, which is correct. Diba kanang any triangle is congruent to itself since pareha naman sila, so congruent jud. Next is symmetric. So if T1 is congruent to T2, then T2 is congruent to T1. Diba? If si triangle 1 is congruent kay triangle 2, but it's just the same as triangle 2 congruent to triangle 1. Okay, so it is symmetric. Next, transitive. If triangle 1 is congruent to triangle 2 and triangle 2 is congruent to triangle 3, this means that triangle 1 is congruent to triangle 3. So it is transitive. And that's all. Thank you.